All right, everyone, we're live. Hello, everybody. I'm so glad that you're joining us here at JConf. My name is Jim Manico. I'm going to be your speaker for this hour. And we're nearing the end of JConf. And hey, thank you to all the people who made this conference possible and put the work in. I'm excited to be here. So we're going to talk about application security. We're going to look at a new standard, the OWASP Top 10 recent release, just released a couple months ago. This is one of the lead talks. This is one of the lead like semi-standards when it comes to application security. It's something that's good to be aware of. But let's talk about what this is. Now, what is the OWASP Top 10? OWASP is the Open Web Application Security Project. It's an Apache-like organization that focuses on web and API security. And the foundation releases a plethora of tools and documentation, and we run conferences all around promoting application security through a charity entity, a 501c3 charitable service for education. So now what the OWASP Foundation does is they release a top 10 list on web security on a 3 or 4 year cyclic basis. And so this is a de facto standard. And I'm using the word de facto for a reason, because it's not a standard. It's a freaking top 10 list, right? The freaking top 10 list is meant for awareness. It's meant to have talks like this, to talk about web security. It's not something you should base a program off of. So this is a warning indicator when I'm evaluating a company's application security. Is the standard of your company, will we address the OWASP Top 10? Well, then you're not doing complete application security. It is meant for awareness. Now, the project members who run this project are security professionals all over the world. The 4 leaders include a data scientist. We collect a lot of data, analyze it to pick 8 of the top 10, right? 8 of the top 10 are data-driven. The other 2 are from a community vote. So we include both the experience of our security members as well as what data science says around vulnerabilities in this era. Now, let me focus on this one more time. The OWASP Top 10 is often misused. This is a little snippet from the OWASP Top 10 document itself, and it says, look, if you're going to use the OWASP Top 10 for awareness, that's great. But for anything else like training or design and architecture, it's the bare minimum. I do teach the OWASP Top 10 in my own training courses, and it's one module out of like 50. So I want you to be careful. The OWASP Top 10, it's a great top 10 list to breed awareness, basic awareness around application security. It's not comprehensive, nor is it meant to be. It's meant to show you the most critical things we see in this era of time. There's the OWASP Top 10. Now, what's new about it this year? We've had multiple releases of this since 2003. So what is this version all about? You're going to see some new categories. In particular, insecure design. You're going to see software and data integrity failures, and server-side request forgery shows up, which is, we've had multiple incidents in the world of SSRF. I'm going to go through all 10 with you. I love number 1. Number 1 comes from the 70s, from Dr. Salter and Schroeder doing original white papers, quoting the term principle of least privilege. It's almost as old as me. It's like almost 50 years old, right? Broken access control. Why the heck is broken access control, something we've known about for decades, the most critical risk facing software? Well, let's look at the data. 94% of apps that we tested as part of this project had some kind of broken access control. There's 34 common weakness categories that map to access control. There's a first step. This is the stat of 94% of reviewed apps have broken access control. That's pretty significant. But I want you to look at this from my point of view for a second. Access control is difficult to test from automated tools. Think of the era of security we're in, DevOps. What's the heart of DevOps? To run a bunch of automated testing, usually turnkey automated scanners. The automated turnkey scanners that you buy, the code analysis, the application scanning, and the third-party library scanning are useless to find access control problems. Wait a second. This is a big deal here. The number 1 issue we're looking at is access control by the stats, and the main tool suite of the day that we use for security assurance doesn't find access control. Why is this? Because your security scanning tools are not aware of your access control policy. Access control is a business logic domain because everybody's app has a different set of policies for access control, and your scanners don't know what your policy is when you use off-the-shelf scanners that you haven't configured. Also, access control at some level can be challenging for developers to build. Here's what I mean by that. Now, basic role checks are trivial, but what about horizontal access control, where I'm checking if a user can access a certain piece of data? Or what about multi-tenancy, where you need different access control rules for different customers, or other difficult access control features? Rarely do I see architects providing that capability to me. I got to go figure it out. That's a problem. So let's go back a step when it comes to access control. This is indirect object reference, one of the main access control problem categories we've seen. In the simple mail system, I have some kind of API, I got a REST hit, and I'm looking for a certain message. How would you hack this particular URL to steal other messages? I just changed the number. And it took me 5 minutes to write a script to try every single number if I was a full-time employee. If I was a contractor, that's a 2-week project. I digress. The point I'm trying to make is attacking the access control of your apps is easy. And at this level, change the number, any number, through a request, through an API hit. And if that lets me see data that I'm not supposed to look at, you have an access control problem. Now, here's the sequel, right? I'm selecting data from messages for a certain message ID. That's also vulnerable to tampering. So one of many solutions, the key, one of many solutions is in the query, I'm going to make sure that the current user ID that I pull from session or that I pull from a validated job, I make sure that that user is the owner or the recipient of that message. And now at the query level, nobody can steal data unless they're the owner or they hijack an account. The point I'm trying to make is that to solve this problem, I have to figure it out on my own. And if you're an architect and you have this need in your application, which you probably do, then you should establish a standard around how all your other developers can implement this kind of access control. Our frameworks almost never have this kind of capacity built in. We got to build it ourselves. That's not good. Another piece of access control is I don't believe in hard-coded roles. I think if your app is hard-coding roles, you've made a terrible design decision. You should not be hard-coding roles. You can have roles in the back end as part of your data structure, but access control should be enforced as a policy enforcement point, as a feature, not as a role. Roles are part of your policy. Don't hard-code it. It makes multi-tenancy and other things more difficult. Instead, hard code the name of the feature and push your access control rules to a database. You code it once, you never change it again. It implies your policy is centralized, persistent, requires a lot more design work upfront to get right. And this will allow any other complicated access control feature that comes up to be implemented in a cleaner way. And it also decouples your code from the access control database or functionality, which is pretty critical in complicated software. A few other quick concepts around access control. Again, enforced by the activity or feature. Please don't use roles for policy enforcement. It's a horrible design. It always was. Implement data contextual access control so you have a standard way of addressing data-specific checks. That's for you architects. Build a central access control mechanism. Design it so all requests go through an access control filter. So all requests must go through your access controller. Deny by default if things go wrong, fail securely. Use the right data for an access control decision. Don't have a role be a cookie where I can edit it and change my role. Be able to change a user's configuration for access control in real time. I make the change as an admin. That should take effect to that user immediately, even if they're currently logged in. Build grouping, and here's a good one in my opinion. Build your admin screens first. When you're building an access control mechanism for your enterprise, get the admin screens done first, at least mocked up. So folks who need to manage this metadata, they understand what those admin screens are. Very often I have a non-programmer managing the app for big companies. A few other notes, go take a look at the application security verification standard. The recent release is 4.0.3, and these are the collection of access control requirements that you can use to enhance your own standards for access control. And access control that's complicated is brutally difficult to add late into an application's lifecycle. So what I mean by that is if you've made a weak access control design and you have to redesign it mid-flight, that's painful. So please, of all the security designs you're going to look at before you build an app, really go out of your way to get access control right up front. Really hard to rewind it when you're deep in an app. Here's a couple other guidance from NIST 800-162. That's the federal government's access control standard on ABAC, attribute-based access control. The authorization cheat sheet from OWASP. Here's the requirements. And this presentation, I'll give you a tiny URL at the end so you can grab a copy of it and see all these references for yourself. As we continue marching through the OWASP Top 10, 2 is cryptographic failure. Now, this category used to be called sensitive data exposure, but the loss of data is a symptom, and the root cause is we built crypto incorrectly or have broken crypto in some way. Crypto is a brutally difficult topic. And I love Java, but I would not use Java low-level coding for crypto ever. I'd use a higher-level library. I'll get secure crypto way more if I'm using a vetted library than to try to do it myself in low-level Java. And that may not be a popular opinion, but I think it's a fair one. So number 1, how often should we use TLS? The answer is everywhere. There's rarely a good excuse not to use HTTPS in your web apps. All connections don't tolerate plain text sensitive data anywhere. It's not wise. And we want to use things like strict transport security and other ways to enhance our TLS so it's as well configured as possible. Also, key management is becoming more important, especially in microservices where we're using JSON web tokens. We want to be ready to generate, establish, store, use, destroy, and especially change our keys as rapidly as needed. Also, we don't want to store keys. I prefer to keep my keys out of like Java's low-level key manager. That's not robust at all. I make sure that I'm usually using a higher level library like Google Tink, and I'm connecting with third-party secrets management services in the cloud, right? Like AWS Key Manager, or I'm using HashiCorp Vault, a formal secrets management software. So my developers don't have access to keys anymore. This is a critical part of key management. My devs don't touch keys. What they do is they reach into a vault with their data and operate on that data without exposing the key to even the dev in any way. Let's go a little further in this. Secrets management is brutal. I love this article from Cash App that they show you have one main key in your key manager. You have that encrypts a service key, which encrypts data level keys. So I'm never storing a key. I'm just storing ciphertext, and I can reach into my KMS to be able to do my decryption operation or similar. This is why I like this is because these key managers are expensive and don't scale well. This is a much more realistic take on key management that handles scalability at any level you need. I'm really impressed by the depth of this article. And again, I don't think you want to use the low-level Java language to do crypto at all, folks. Instead, I would use Google Tink. It's a great Java library and one of the top Java libraries. It's multi-language. I can now do crypto interoperably between a variety of different languages. I can encrypt in Java and decrypt in Python. Python is dead to me, by the way. I did one Python program. I had a space wrong and it wouldn't compile, and I'll never use Python again. I prefer the verbosity of Java. Thank you very much. All right. So anyways, and also why I like Google Tink, this Java first library, it integrates directly with secret management. Ooh, I can whip out Google Tink. I can use a KMS, get this set up, and do pretty decent crypto in a very short amount of time when I'm keeping away from the insanity of doing low-level Java crypto, which is really complicated because of all the different support they have. I think this is a better way to go for 99% of developers, right? Also, there's libsodium. This is another crypto library with fantastic primitives, out of the box, easy to use. So crypto, I mean, we can talk about crypto for an unlimited amount of time. It's a big topic. But here's the TLS cheat sheet. Here's an evaluation engine, SSL Labs, to check your own site for free. There's the OSAFT and Test SSL projects that are turnkey scanners from the open source world to check your internal services for TLS configuration, and the cryptographic storage cheat sheet to give you some design tips on modern crypto. We're still looking at the OWASP Top 10. Hello, everybody. We're looking at A3, SQL injection, just briefly. SQL injection used to be the top category for years. This is the first time it's sliding down off of number 1 to number 3. It's something we know a lot about, right? I hope you're screaming parameterized queries. That's the solution. Applications that insert untrusted strings into database queries via string concatenation leads to SQL injection, right? And these injected queries run in the context of the application account, allows full read-write access and worse. Where's the vulnerability? Here's a little bad Java, forgive me, but that data, this is so important. I got to get the pen out for this. Yeah, that variable, you should not be using string concatenation at all to build a query. So when I look at code like this, right away, it's either straight up SQL injection or it's badly designed code. It's still badly, even if it's not injectable for some reason, it's still bad to see this in a function. How do you fix this? Somebody say validation. Validation. No, it's not validation that solves this problem, damn it. So here's what I mean by that. Is this a legit email? Yes, it is. It's a fully legit email. It's live right now. Every RFC on email in history, it's valid. And you don't believe me? Send me email there. I'll respond to you. If you email me at my SQL injection email, I'll respond with one word: believe. Here's the HTML5 standard on what an acceptable email address is. Oh, there's my single quote. There's my equal sign. There's my exclamation point. There's a dash in there somewhere right there. I got all the characters I need to give you a valid email address that is injectable. There's my valid email address, and I add it to a query, or 1 equals 1. There it is right there. Or 1 does not equal Manico. That's always a true statement. When you add or true to a query, boom, I got the whole table. So look at the title of the slide. Even valid data can cause injection. Input validation is important, but other mechanisms to secure your software is even more important, like parameterized queries. Always parameterize your queries. There, no string building, right? I'm using a parameterized query. I'm using variable binding. I get better performant query interaction, and I get security. We love security. Sometimes you can't parameterize a variable. Do exact match validation and be careful. Get an architect to help you, because every once in a while, you will run into a variable that can't be parameterized, like a table name or column name. It's usually a design flaw. So if you want to learn more about SQL injection, you got Bobby Tables. We got the query parameterization cheat sheet. This topic was first talked about in 1998 in Frac magazine by Jeff Forrestal. We've known about this for 20 years. Make sure all your developers are rigorous in parameterizing their queries, and use some kind of static analysis engine, SemGrep or something, that's going to double check your code to make sure you're not allowing check-ins with SQL injection. Up the stack. Now, another category in the world of injection is cross-site scripting. This is also an injection category. Like if I ever have a piece of untrusted data that the attacker can modify, and that lands in a user interface, this is what leads to cross-site scripting, or one way that leads cross-site scripting. As the attacker, I can just modify that to be an evil script. It's hosted on my server or any server. And now I'm injecting script into your site that executes JavaScript from me, the attacker, not JavaScript from your developers. And so there's a lot of different ways I can launch this attack. This is an example of how I can steal a cookie. And again, I inject this into your browser. This code lands in your browser as a victim. It grabs the cookie, adds it to a URL, and sends that URL to a server that I control as the attacker. I can also deface the site, right? Document body inner HTML, right? The most filthy, cheating, lying, despicable, disrespectful team in the NFL is, of course, the New England Patriots. And the good teams in the NFL would be any other team except for the Patriots. Now, Brady is not with the Patriots. So I say any team that Brady's on, he's a lying cheater too. He deserves to be booted from the NFL. Brady. So let's move on. Now, that's just my opinion. You may disagree with me, Bostoners, because I know you have cult-like worship of the Patriots. It's okay. It's all right. This is editable. But the whole point is I do my little loop. I do my defacement. Document body inner HTML. I overwrite the whole body. So if you let me submit a script that has this overwrite, I can easily deface your site in a pretty trivial way. When I'm having a bad day, I just play this script and just look at it for a while, and I feel better. Let's move on. Now, cross-site scripting defense. If cross-site scripting defense was a Facebook relationship status, what would it be? Be mine. It's complicated, very complicated and important. It's complicated. And so if you're trying to display data exactly like it was typed in coding, if you're trying to allow a user to author HTML safely, then use an HTML sanitizer and use the right safe functions in JavaScript that don't lead to script execution. Also, make sure you sandbox third-party garbage. Make sure you serialize JSON properly in the browser. Make sure you're considering content security policy and libraries that support trusted types. It's complicated, unfortunately, Facebook status. A4, we're now on level 4 of the OWASP Top 10, looking at insecure design. Insecure design is this concept where we should think about security at the design level and then go write some code. I know it's funny. I know it's kind of funny. I know. Think through security first in your design and then write code. Please stop laughing at me. I know it's this avant-garde idea. It's the idea that we prepare a design, consider security architecture before we make the change. I know developers, you're thinking, but what about coding? I know it's kind of hard. Just wait. What we're saying is before you code, to think it through. I know. I'm a little out there on the edge with this crazy idea, but that's all that threat modeling is. It's about drawing pictures of your software and then simulating security attacks against that software. That's all it is. And believe me, there's formal methods out there. Here are my favorites, right? By the way, I don't like threat modeling. I like code, but threat modeling is important and you should acknowledge it and work with it. I'm going to give you 2 presentations. Avi Duguland, these are developer-centric threat modelers, which is why I like him so much. Avi Duguland, Avi Duguland is like one of my favorites. He teaches as a contractor for me. I love his style and his developer-centric approach to secure design. Tony UV has a method called PASTA. He's another developer-centric threat modeler. So if you care about leading threat modeling sessions, which is a software design analysis for security, if you care about secure design before you write code, stop laughing. But if you do, check out these presentations. They're world-class. These are my mentors when it comes to secure design, right? Reference architectures helps here a lot as well. I'm going to stop. A5, security misconfiguration, right? This moves up to number 6 from previous editions. 90% of apps we tested had some kind of misconfiguration somewhere in the stack. And previous vulnerability categories like XEE from the XML attack category world, that's all about configuring your XML parser correctly. And by the way, if anybody has any say at Xerxes is still in use and it should not allow this. They should turn it off by default. Boo. A lot of the Java world, like the Java level XML at the native language, they've turned this off by default for years. This is a good thing for XML. All right, let me move on. The point I'm trying to make here is when it comes to security misconfiguration, it can span anything from password length to file permissions and more. And you need to RTFM, read the freaking manual for your framework, for your deployment environment, and everything else in between. When I'm working on a new framework, I either hire an expert in that framework to school me, or I look up different hardening guides that came with that are out there for that framework. Like Here we go. What do we got? We got Django, we got WordPress, we got Struts, we got Spring. Every major framework and language has a hardening guide. You want to get one, vet it, and actually use it. Hopefully build a golden image of your framework, all configured, that you then dish out to developers in their dev environment. RTFM, read the manual. One of the examples of configuration is TLS, right? Like I use the Mozilla SSL configuration generator to set my server up. I get myself an A+. Go check it out. SSL Labs. Go hit these, test your server, test my server, test other servers, and you can see how well that server has TLS configured. You should be A or above, in my opinion, right? And again, when it comes to XML problems like XXE and the billion laughs attack, all these attacks against the rich features of an XML parser, here's a cheat sheet that describes how to configure multiple Java interfaces from the world of XML problems. And probably you should be using JSON. Come on, folks, give up on XML is a dead standard. Don't use it anymore. New projects, choosing XML is almost always a really bad idea. It's a JSON first world, and JSON is radically safer as a parser to be parsing untrusted data. I digress. So this huge category, everything from the OS to the framework. And if you can't verify your configuration, assume it's not secure. Read the manual, go through hardening guides, get proper testing, and cloud. When you're moving to the cloud, right? You got Oracle, who has an awesome cloud server. Go make sure you are configuring the administrative areas of your cloud service properly. And it's non-trivial to do so. Requires significant expertise to administer cloud services. Do it right. OWASP Top 10, number 6, vulnerable and outdated components. Yeah, this is something we've all been facing the last couple of weeks, last month or so, right? So when we did the analysis of the data a few months ago, it was number 2 in the top 10 survey and number 9 based on data analysis. Yeah, and so it's number 6 in our list. But if we consider the data from Log4Shell, the Log4j problem, this would easily be the number 1 top 10 issue by a wide margin because the impact from this has been off the chart. And so here's my question to you. We're now at the détente. We're at the end of Log4Shell. I mean, it's going to trickle around for decades, for years. But the main problems with Log4Shell for most of us are coming to an end, right? Or the stress is less now. Here's my question for you. It's important to be self-reflective of your flaws, folks. You gotta face the shadow. So let's talk about this. When you were forced to update Log4j across your inventory, was that something you could realistically do in a couple days because you already were used to updating libraries? Or did you have software that you weren't updating and it became immensely painful to update these libraries? You want to analyze your SDLC in terms of update ability. How strong, how frequently am I updating libraries, and how strong and rapid is my process to do so? And guess what? We all across the world, we just got tested on this. I saw some of my customers, I'm talking really big software developers, had this whole thing licked in like 2 days because this is a characteristic of their SDLC. They already matured. Other companies are still struggling with it because we never update libraries. Who cares? Well, security cares. Security cares a lot. And here's a big lesson for all of us, right? And so just this year, I also saw like 2 of the biggest frameworks, WordPress and Drupal, had major critical vulnerabilities pushed live because of third-party library tools. And so because of third-party libraries that were out of date. If you're not running third-party library scanners, please start doing so right away on all of your software, including legacy projects you're not working on anymore. So we have OWASP dependency check, Maven security versions, retire.js for JavaScript. You can run Dependabot and GitHub to automatically PR you when there's an out-of-date library. Run a tool, run it every day. hey, what should your service level agreement be in terms of updating a third-party library when there's another event like Log4j? I believe it should be about 24 hours because we saw Log4j was already being exploited by the time Free Wortley at Lunasec actually was. He's the original poster about this in the West, right? Chinese Twitter was raging about it, and they were actually exploiting it. Free Wortley is one of the first U.S. engineers to see this, tweeted it out, and pushed out a blog post. And so you should be able to react almost instantly to a future event that is going to happen. Let's move on. We're now looking at A7, identification and authentication failures. Now, this is critical because it's such a ginormous topic. We used to call this broken authentication. It's a little less severe of a topic. It's down to 7. It used to be up the stack more. But we see that less and less, and this should be the case for you developers, less and less should you be building identity frameworks or building a login system from scratch. You don't want to do that anymore. There's so many standard frameworks and identity providers that will handle this for you. I think it's rare when you should be building a login system and an identity platform from scratch. There are too many other established frameworks that are very well written that are out there already. And the requirements on you to build a simple login page is dramatic, from password storage to OAuth 2 support and more. It's non-trivial. Don't build this. You buy it, use it, open source it. So question, and keep it up to date. What is authentication? We're just establishing identity. What's a session? That's what I'm using, a JOT or a server-side session to track a user when they're logged in. What makes this topic difficult is there's so many subtopics. And a basic identity course is like it's like 8 hours, and a comprehensive identity course is like a week at least. There's too many little topics here. Now I'm going to start with this: how strong should your digital identity solution be? How strong should your login system be? Should you be using a password only? Should it be password and multi-factor challenge? Should it be a YubiKey or a dedicated cryptographic key? Now, I have my instinct on these things, but there's the standard, not new, but still relatively fresh. NIST, there's a National Institute of Standards, special publication 863.3. I love this standard because it gives me a real standard to point to when I'm telling customers how strong their login systems should be. And there's 3 levels of assurance that we're looking for. Level 1, password only. Level 2 means it needs some kind of multi-factor. Now, let me be specific here. What about SMS? AAL level 2 in NIST 863B says if you're going to use SMS for multi-factor, it may not be the only factor you're using because it's weak. So if you're going to offer SMS, it needs to be the second offering. And your first offering for multi-factor should be something stronger than multi-factor, like app level multi-factor. And SMS can only be one option. If you're only certain, now hear me out here. If you're only using SMS for multi-factor as the only option available to me, NIST says you're AAL level 1. You're no more than password only. And that's not what you should use for sensitive data. So if you're using multi-factor and it's only SMS, and I'm looking at you, Chase Manhattan, one of the biggest banks in the world, you got to offer stronger form of multi-factor, especially for high-risk software. And AAL level 3 means your critical infrastructure. Use a YubiKey, use a smart card, use a cryptographic chip that you give to a user. Now, here's the workflow for NIST Special Publication 863.3. That's the overview standard. I've also mentioned 863B. That's the authentication part of the standard. So how strong should my login be? Let's say the only thing I care about is a low risk of sensitive data and the rest don't matter. That's all I care about. I have sensitive data and there's a low risk it might leak. So let's go down this list. Do you assess high for any of the above? No. Do you any personal safety? No, it's just sensitive data. Moderate? No, we're low only. Do you assess low for the release of sensitive data? Why, yes. Then you should be at AAL level 2. Let me interpret this for you. If you have sensitive data in your app, then you should be offering multi-factor, and SMS by itself is not enough. You should be offering SMS and a stronger multi-factor like app level, like app sync and so on. A lot of people don't follow this. A lot of password-only sites out there with sensitive data. There's a lot of us, like big banks, only using SMS multi-factor, and that is not compliant to US standards from the National Institute of Standards. So identity, multi-factor, we need it. So modern password policy, this is also pretty different, right? First of all, if you limit characters of a password, it's doomed to failure. And if you have too big of a password and you're using the right protection algorithm, that can lead to denial of service, your server getting shut down. So let's start with this. Minimum, we want an 8-character password. You should support up to 64-character passwords to support password generators, and no more than 128 for performance. That's a guesstimate, but it's good enough. Also, let's look at the standard now. This is 863B. They're saying don't limit the character type. The character size should be 8 minimum, but keep in mind that if you have sensitive data, you should use multi-factor. So 8-character passwords in that context make perfect sense. Block context-specific passwords like the username or the word password or your business name. Check against a list of 50,000 or more of the world's most common passwords and block it. Check against a list of breach passwords using services like Have I Been Pwned from Troy Hunt. So a password that's already been breached and leaked is not an option for your users. Throttle, somehow manage brute force. Don't force unnatural password special character rules. That's controversial. Drop them. Don't use password security questions. They're in Facebook. No more expiration for the sake of it. It doesn't help security. And force the use of MFA anytime sensitive data is in play. A little poem. You're welcome. Okay. The new rules of is this a good password? Heck no. Why? It's the 32,000th most common password in use today. It's got the word password in it, and it's part of public breaches. There's a lot of reasons why this is a bad password. Let me ask you a question. What algorithm should you be using for password storage? Well, here you go. Argon 2 ID is the way to go. And I'm giving you specific configuration options. If you don't want to use Argon 2Y, you can use bcrypt. I say no to bcrypt. Bcrypt truncates 72 bytes. That's not in line with NIST standards. I'm supposed to say bcrypt is okay, but I'm not going to do that. Bcrypt is junk, garbage algorithm. Stop using it, please. It truncates. It's got weaknesses, and don't prehash. It breaks things. No, stop using bcrypt. Use Argon 2 ID. It's native. You got it in Java somehow. I think through Bouncy. I don't know exactly, but Argon 2 ID is out there. There's your configuration setting minimum. Switch it out now. I'll wait while you switch out your password storage mechanism. I'll wait. You tell me when you're done. All right, I'm gonna stop that. So scrypt is decent. And if you're FIPS 140 federal government, you want to use PBKDF2, password-based key derivation function 2 with 310,000 or more iterations if you're using HMAC SHA-56. This cheat sheet has many other configuration options out there, and take a look at them, right? They'll help you whatever you're using, even bcrypt, even bcrypt. If you're using it, it'll at least give you a little more guidance on how to use it correctly. I'm going to leave it at that. There's some password storage for you. So we talked about identity here, and this is a hard topic. Here's a few references. You got the ASVS requirements for authentication. The ASVS, that stands for the Application Security Verification Standard. There's your requirements for session management, and there's NIST 863. This is the digital media identity standard for U.S. government. And Canada looks at this. There's other countries that do support NIST standards or use them in some way. We're nearing the end, right? A8 is software and data integrity failures. This is a new topic. It focuses on making assumptions related to software updates, critical data, and pipelines. And so I'm going to get right to this, right? And so this is not my main. something we talk about briefly is what I'm trying to say. The main thing I care about is the rule of two. Remember Santa, he checks his list not once, but twice, right? That's Christmas. Sorry. So be very wary of scripts that you download and run daily. And I'm looking at you, DevOps pipelines. If you have a mature pipeline, you're probably running 4 or 5 scripts that you download and run from one of your customers, from one of your vendors. That's dangerous. That led to the code cov and other incidents that led to remote code execution through the DevOps pipeline. So my solution is the rule of two. When I'm downloading a script, I'm going to automate it, but I'm going to first check to make sure it matches the published download hash. And then second, I'm just going to verify the script contents against the published repo from that vendor. If they're going to make you download and run a script, they're almost always publishing it on a repo. So when I'm going to run a script from a vendor source and just run it as root in my DevOps pipeline, first of all, that's crazy. And second, I'm going to verify it at least twice if I can get away with it. A9, security, logging, and monitoring failures, right? When we look at A9, I think that the most difficult thing here is how do I get developers and how do I get my security team to agree on a logging standard, right? Because the way to start with logging is you have security teams who want to look for certain events, but you got developers who drive those events. Have a quick meeting between dev and security, establish a logging standard of what attack events you want logged. I'll explain in a moment. So the goal of logging is to alert on specific security events. Here's the app logging cheat sheet. This was donated to the OWASP Foundation by the Apache Foundation, by Nike Corporation. There we go. And Nike gave us their cleaned up version of their logging standard to help you and your team have a base standard that you and your developers and security team can all agree upon. This is very comprehensive. Things like you should be logging if someone's impossible travel, like they're giving me an IP address that's geographically impossible to get to from the last request. Or if I'm logging in successfully after so many failures, want to log that. And 100 plus other events to consider. This is a great place to start. And again, who's also one more note is that your SOC teams is like your network operations center team. You might be doing the world's best logging developers, but the bad news is your network teams are rarely intaking the full app log well. So the way to solve this is we got to standardize security events on the standard and understand what is and is not normal from the security team. So they're telling you what to look for. You log what's not normal, and they now see it in the logs. It's going to be a much, much better process for your team. And again, this was donated to the OWASP Foundation by Nike. It's the logging vocabulary cheat sheet. I'm really excited about this. I use it in my own courseware now because it's the first comprehensive standard that's specific to application security around what to log from a security event point of view. Folks, all stories have a beginning. And yes, that's right. All stories have an end. Our time is coming to a close. We got one more topic, though, and that's going to be server-side request forgery. I think a fascinating category. So this category did not pop up in the data analysis. This is the category that only came about because of the votes from the community. And this makes sense because SSRF, server-side request forgery, is an attack category that spans multiple servers. It's not easy for the scanning tools we depend upon to find this reliably. I think the first big event was from Capital One in August of 2019. I remember the day well because I just finished making oatmeal raisin cookies, my favorite cookie. Chocolate chip are dead to me. Your snickerdoodle, dead to me. Your peanut butter, dead to me. The platonic form of cookie is oatmeal raisin. No nuts, no chocolate. I heard that, Joe. No nuts or chocolate. Pure, organic oatmeal, low sugar, raisin cookies is the platonic form of the cookie. And I just made some when I was eating my cookie and drinking a tall glass of almond milk, organic, low sugar almond milk. I'm drinking, and then all of a sudden CNN says Coming up next, server-side request forgery. And I started laughing and milk out my nose because I thought someone hacked my TV. There's no way CNN's talking about SSRF. That's my first reaction. One of my friends is playing a trick on me. I'm like, oh, unplug my TV. And it was real. What happened was really simple. There's this one. So this is a capital one URL. There's this one variable that was a server-side include. That URL was a URL that the server acted upon, and it wasn't validated. And they're hosted on Amazon Web Service. So the attacker, who was an ex-Amazon Web Service employee, and she saw that Capital One was using this URL, had another complete URL, and she changed it to be an Amazon intranet address. So this entire request went to Capital One. They grabbed that parameter and went and loaded and embedded that resource onto the page. The attacker changed it to be an intranet file that ironically was the web application firewall configuration file. And in that configuration file was the username and password to AWS. The attacker then logged in to AWS, went to the S3 bucket of Capital One and began downloading 100 million credit card applications and all the PII private data within. By the way, when she began to test this endpoint a little bit and see what was going on, she was a security researcher. When she got the credentials and logged in and began downloading applications, she became a wanted felon. So the line between researcher and criminal can be thin. Don't do stuff like this. She should have a great career. She should not be in jail. That's where she is. SSRF happened at GitLab early last year. This is, again, critical infrastructure. It allowed the attacker to build a webhook that could make any authenticated request inside GitLab's private network, right? We had Microsoft Exchange. Nobody should run Exchange. Stop, full stop. If you're running a physical Exchange server, go unplug it right now. I'll wait. And go use a cloud service, please. The chance that you can keep Exchange up to date as well as a cloud service is minimal. So again, those who are using like Exchange 365, boom, they had the update instantly. Those of us running our own servers, horrible. Plenty of solutions from Oracle as well. All right, I'll give a little nod to Oracle in this role, but please be careful here. Here's Exchange. This allowed attackers to attack your physical Exchange server and forced Exchange to make an internal request as an admin. Like 30,000 US companies got rooted because of this. Yeah. Now, keep in mind, other ways this can happen is I'm sending data here that gets sent out to your back end. Look at it this way. A, I'm just grabbing some parameter from your request. And B, I'm taking that untrusted parameter and adding it to a URL that the server then acts upon. My question is, how do you add a variable to a URL safely? What's the right answer? How do I add a variable to a URL so it stays on that path and doesn't allow path traversal? Now, path traversal would be something like this. Here's the data, here's the parameter, and here's my attack. Path traversal. It will change where the server request to that internal server lets me change from some data element to an admin report just by modifying the request. And that's what this is all about, right? So let me clean this out for a second. So I make the request in step A, and that variable is added to a URL, which the server acts on in step B. And if you're not protecting that variable, I can change the path that the server change the path of the request that the server makes to other resources. And that's a problem. How do you solve this? URL encoding. So I usually want to use two functions. If I'm going to add a variable to a URL, I have encode for URL path and encode for URI parameter, both different kinds of URL encoding for these specific use cases. Now let's wrap this up. I'm almost done, folks. So how do you stop server side request forgery? It's what's the Facebook status? It's complicated. So great authentication on your intranet APIs. Anybody, do you have a backend network with APIs that don't require authentication, don't require access control, and don't have TLS, but they're on your private network? Stop that. That is a terrible architecture, no matter how you look at it. And it's a common architecture. We should do what like Google standards. Every API you deploy should have strong auth, strong access control, TLS only, and you want to protect the individual APIs. If you assume that you can use this API because it's coming through another service, that's almost always a bad idea. I digress. When a URL is a parameter that the server acts upon, strong validation or get rid of the feature or build around it, build something else, right? Also, you can, when you're going to add a variable to a URL that the server acts upon or any URL, do proper URL encoding when you add a parameter to a URL. And you can even use network controls to limit what your server can do from an outbound point of view. Alexa, play some heartful music. See Alexa.
It's harmful, but camouflage on Amazon Music.
As we finish up this talk, a few final notes, right? We really want to develop secure code. I want to ask you to go take a look at the Application Security Verification Standard, read those requirements, and let me know if you have any questions. Also, take a look at the OWASP Cheat Sheet series. This is something that we spent thousands of hours on. It's a living encyclopedia of secure coding knowledge. Also, take a look at our testing here. You got OWASP. It's a free testing tool from the open source world for your web apps and APIs. OWASP Dependency Check. Take a look at that. That will help you. Look for your third-party libraries and make sure they're not out of date from a security point of view. For static analysis, I like SEMGREP. SEMGREP. It's free. Also, we have the testing guide so you can learn more to be a security tester. I am done for the day. It has been a pleasure. If you have questions for me, I'm jim@manico.com, and you can grab a copy of this URL, a copy of this presentation at tinyurl 5 feet 4 BCUU. You can go grab the PDF. It has been my pleasure giving you a talk today, and that's my story, folks. That's the end of my story. I'm gonna bop out of here in just a moment. If you have questions for me, I'll be in the private chat for a few minutes. Thank you for attending JConf. Thank you for your support of the Java Champion community. Thank you to the Java Champions for giving talks, and thank you to Ken for organizing all of this. Thank you, Jesper. We're done. That's it for me.